Okay, so we're going to talk about positive, negative, zero. You're probably used to talking about the zero part already. You know how to find zeros of your functions using your calculator. Hopefully you can also identify that when you're just looking at the graph. So we're going to start with identifying where it's equal to zero, because where it's equal to zero is usually where it changes from positive to negative or vice versa. So let's look at this first one, this linear function. Obviously, we have one place where it's equal to 0. So it is equal to 0 at x equals 4. At x equals 4. If you want to, you can kind of draw yourself a little line through that like we did yesterday, so you can see the change. Okay, to the left of that 0, our function is negative. So we are negative. We're going to use interval notation again, and we're moving left to right. So we're starting with that negative infinity all the way there to the left until we get to 4. Our function is negative, and then it becomes positive after we pass 4, and it remains positive for the remainder of our function there until we get to positive infinity. Okay, so linear, pretty easy, only one change. Let's look at the quadratic function. Y'all know that quadratics, most of the time, not all the time, but most of the time, they have 2 zeros, or it is possible for them to have 2 zeros. It's also possible for them to have 1 and none. But this one does have 2. One of them occurs at -1. The other one occurs at +3. So let's go ahead and write those down, zeros. I think that's supposed to have an E in it. X equals -1, and I'm just going to put a comma and list 3. It's not a point. Don't put parentheses around it. I'm just listing the 2 different zeros. All right, so again, left to right. So on the far left, our function starts out, and it's negative. So it is negative, starting from the left, so starting from negative infinity until we get to -1. Then our function is positive between -1 and +3. We have positive y values, and then we go back to negative from 3 to positive infinity. Again, be careful with this. Yes, the function is negative. It is going down to negative infinity, but we're using the x values here just like we did with our increasing and decreasing intervals. Okay, again, the key is where. Where is always x. Where is always x. All right, let's look at that square root function. It has 1 0. Square roots don't always have zeros, but this one does. It crosses at +1. So our 0 is at x equals +1. The y value is 0. And this one we start out and we're negative. We don't always start out negative, but these 3 functions have. So from negative infinity until we get to that +1, our function is negative. And then our function is positive from +1 until 3. Okay, it doesn't go to positive infinity because remember, this is the function where it stops. It is not defined past x equals 3. 3 was our cutoff. Our domain is x is less than or equal to 3, so our interval there is going to end at 3. Questions? Pretty simple. Well, we could put brackets at the 3 there because it is equal to 3. I'm not going to get super nitpicky over that. I typically just use parentheses with positive and negative because like at the 1, at 1, it's equal to 0. So we want to use a parenthesis there. But technically at 3, the more correct notation would be to use the bracket because at 3, it is positive. Okay, but again, I'm not going to get super nitpicky over that one. But good detail. All right, let's look at the absolute value on the back. Like the quadratic, it has two zeros. One of them is at -2. One of them is at +2. X equals -2, +2. If you wanted to, you could do plus or minus 2. I don't care how you express that. This one starts out and we're positive first. So I'll list my positive. But we start with negative infinity because we're using the x. All the way to the left is negative infinity until we get to -2. Then our function is negative from -2 until +2. And then it goes back to being positive from 2 for the remainder of the function all the way to positive infinity. All right, number 5. We have two zeros on number 5 here. One of them is at 0, at the origin. The other one is at +2. X equals 0, 2. So our function here starts out negative. You can abbreviate that as well, NEG. So where does our function start? This one does not start at negative infinity. This one starts at -1, and again, we can use a bracket here because -1 does have a negative y value. So it's negative until we get to 0. We do need to cut this off, even though since to the right of that 0, we do continue to be negative, we still need to cut it off because at x equals 0, we're not negative, we're equal to 0. So we need to cut off our interval there, but then pick it right back up with 0. And I know it looks like I should just be able to squish those together. But because of those parentheses, remember parentheses mean I don't actually equal that number, I just get as close as I possibly can to that number. So that means I'm getting as close as I possibly can to 0 on the left, but then at 0, it's not negative. And then when I pick it back up, I'm getting as close as I possibly can to 0 on the right, but I don't actually equal x equals 0. So I'm just picking back up with it. And that lasts until we get to 2. And then we have a 0 at 2, and then we are positive from 2 until we called it 2.5 yesterday. I'm going to put a parenthesis on this one because remember that 2.5 had an open circle. So technically our function here is not defined at 2.5. It's as close as we can get to 2.5 without actually equaling 2.5. So 2.5 does not have a defined value, so we don't want to put a bracket there. Okay, last one. This one has a 0 at -1/2. I do want you to make sure that you write x equals. I do want you to write x equals just so that you continue to remind yourself, I'm talking about an x value here. All right, this one starts out negative, like most of our functions have. This one also does not start at negative infinity. This one started at -5. So -5 until we get to that -1/2. Notice I do use a bracket on the -5 because -5 has a negative value. And then we are positive from that -1/2 until the end of our domain. It ends at 8. That endpoint was also defined, so it can have a bracket as well. Okay, any questions? So you're going to do this just like you did yesterday with the same problems that you did with the increasing, decreasing. Okay, if it's not a function, then you can't talk about positive and negative. All right, if it's not a function, you can't talk about positive and negative. So do the exact same numbers we did yesterday and identify the zeros and the negative and positive interval.